Welcome to the data structure series. This is the continuation video after creation and insertion of nodes in a singly linked list. Let us talk about deletion of a node in a singly linked list. Deletion can happen at the beginning, at the end, or even in the middle. Let's talk about the algorithm to delete an node in the beginning. So I check whether the list is empty. If the list is empty, I cannot delete an empty list. Fine. So if the list is not empty, I set temp to head. So if suppose I have nodes like 1, 2 and 3, we have learned that head stores the address of the first node. So head points to 1. So now make your temp point to head. Okay. Look at step 3. Head is equal to head. Arrow operator next makes head point to the second node. And now you delete temp. You free temp. And this is how you delete at the beginning. Let's understand the code for this. So the code says if head is equal to null, list is empty. You return. Use your temp point temp to head, make head point to the next node, free temp. That's it. Let's understand the logic better with the help of an example. The example shows nodes 10, 20 and 30. It is deletion at the beginning, so you have to delete 10. Temp points to head and head now points to 20. Free temp, node 10 will be deleted. Let's move on to delete at the end. For deletion at the end, you have to traverse the list to the end and then delete. Yes, so to understand this logic better, the step 1 is you check whether the list is empty. Step 2 is if it is only one node, you delete the node. If suppose there are more nodes, you have to traverse. Yes, so the point is this. Use your temp. Temp will point to your head. Okay, so move to the last node. There is something called as previous. Okay, so finally after your traversal, previous will point to 2 here and temp points to 3 here. I mean temp points to the last node and previous will point to the previous node of the last node. And the concept is make the previous next null and free temp. So this is the logic to delete at the end. Right, let us code the same. So look at the code. You use previous here extra, you check whether the list is empty, and then you do the logic for the first node. If there is only one node, you delete it directly. If there are multiple nodes, you use temp to traverse. Along with temp, previous is also used, and then make previous next null and free the temp, because temp is going to point to the last node. Let us understand with the help of an example. Now the example shows 10, 20 and 30. Deletion at the end. So traverse to the end and delete 30. Is it not? Look, temp is equal to head. Okay, while temp's next not equal to null, what happens? Previous equal to temp and temp points to the next node. Fine. Now again iteration happens. Previous equal to temp and temp points to the next node. So 20's address was 3000. Now what happens? Previous arrow operator next is equal to null, means that 3000 will be made null and you will free temp. Now node 30 is deleted. So this is what is deletion at the end. So now let us understand deletion in the middle or at a position. So for this you have to read the position from the user. If the position is 1, you have to delete the first node. It is like deletion at the beginning. Or else what you try to do, you move to that particular position. Say for example, the linked list contains nodes 1, 2 and 3. Okay, so head always points to the first node. Head has the address of the first node. So you use something called as delete here, del, right? So now what happens, the concept is that now you move to that particular position where you have to delete and make this delete, and this will be your temp. Okay, so you make temp's next point to del's next. Okay, so this is del's next. What is del's next? Node 3. Okay, and then you free this node del. This is the logic to delete at a position. Let's understand the code now. The code reads this. See, you have used del, you have declared that you get a position from the user, check whether the list is empty. If suppose position is 1, it means that it is the first node, you can delete. directly. If suppose it is not the first node, make temp point to head, move to that particular position, and then make del point to temps next, and then temps next will be equal to dels next and free delete. So let us understand this logic with the help of an example. So this is my example. The linked list has 5, 10, 20, 30 and 40. Say for example, I have to delete 20. Okay, so now temp points to head, right? Again, I move to that particular position. Done. So at that particular position, now my del is temps next. So this is my temp. So temps next is node 20. So this is del, right? So temps next is equal to dels next. See, this what happens next is, so this link breaks and then temps next will point to dels next and you free del. So these two links breaks. These two will break, right? Okay, fine. So this is the logic for deletion in the middle or deletion at a specific position, right? So deletion at the end will take order of n time. Deletion at the position or in the middle will take order of n time because we have to traverse n nodes, right? Whereas deletion at the beginning will take only order of 1 because it is direct access, direct deletion at that particular position. Let's understand searching in a linked list. Okay, so searching is again a very simple operation. You get the element from the user to search. You say temp is equal to head, right? Set position is equal to 1. Move to that particular, traverse that particular list using temp. If suppose the key is found, you display the position, or else you display the element is not found at that particular position. Let's code this logic. This is a simpler logic, very easy. This is the code to find out an element at that particular position. Look, position is set to 1, found is set to 0. You get the key from the user, use temp to traverse the list. So you traverse the list to find out the key. If suppose it is found, you say that this position, the key is found. Else you say this is not found. That's it. That simple and direct is searching in a linked list. So traversal of a singly linked list, again a very simple operation. Use temp to traverse the list at the end till the end and print the data. Look, temp points to head. Use temp to traverse till the end of the list and then print the data. That's it. That's it. The traversal of a singly linked list. Done. So this is the summary of the linked list operations, the complexity. So creation takes order of n time. Traversal also takes order of n time because you need to create n nodes in creation, visit n nodes in traversal. Whereas you look at insertion at the beginning, it is a direct update to the head, so it is only order of 1. Delete at the beginning, remove the first node directly, so it is order of 1. Insert at the end, delete at the end, you have to traverse to the last node, so it is order of n. Insert at a position and delete at a position, you have to traverse to that required position, so it is order of n. Searching also may need to check every node in the worst case, so it is order of n. Any doubts, post it in the comment section. I'll be happy to explain. Thank you. Happy learning.